Hi, this lesson is about quadratic functions. Quadratic functions are polynomial functions. They are a type of polynomial function where the highest exponent of the independent variable is 2. So we call it a polynomial of degree 2. So you can have a quadratic function in a form like this, which you've probably seen before. F of x is equal to ax squared plus bx plus c. A is the coefficient of x squared, b is the coefficient of x, and c is your constant. Or it could be written in the form below, which is f of x is equal to a times x minus h to the second power plus k. When it's in that form, you can pick out the vertex very easily. It will be the opposite sign of whatever's in here along with the x, which would be h, and whatever your constant is here. So hk would be the vertex of the graph of this function, which, and we call the graph of a quadratic a parabola. So the second form is considered to be standard form. So this is the standard form of a quadratic function, and you can put a function that's not in standard form, in other words, from this form to this form, by using the completing the square method. Because when it's in standard form, you can easily pick out the vertex, which is an important point to identify in on the graph of a quadratic, which is a parabola. So here's an example. I want to put f of x equal to x squared plus 6x minus 7 into standard form, and then identify the parabola. So the work is here on the right side. You take half of the coefficient of x, which is the 6, and take half of that, and that gives you 3, and then square that number. That number then gets added and subtracted from the equation. So you're basically, when you look at these together, you're basically just adding 0. So you're not really changing the original function, but you are then able to manipulate it to make it look like what we want it to look like. So once I write it as x squared plus 6x plus 9, then I'm able to factor that that trinomial into the difference of perfect squares. A perfect square trinomial, which is x plus 3 to the second power, and the constants here become minus 16. This is now standard form. And in standard form, I can identify that the vertex is negative 3, negative 16. So that would be the minimum point on this parabola because it would be facing upward. Remember, a parabola faces upward when the a is positive, and here my a is 1, and it's upside down when the a is negative. So here we have another one. F of x is equal to negative 2x squared minus 8x plus 1, and I want to put it into standard form. So it's a little bit more complicated than the last one that I did because I have a coefficient in front of the x squared, and you can't apply this completing the square method until the coefficient there is a 1. So what I did was I factored out a negative 2 from these two terms, and that leaves me with this, negative 2 times x squared plus 4x plus 1. Then I'm going to complete the square on the x squared plus 4x part. So half of 4 is 2, and you need to square that. So when I square that, I add that to my binomial, creating a perfect square trinomial. But whatever you add, you have to take away in that same line so that the net change is 0. So if this here is 4, and if you distribute that across, that's actually a negative 8. So in order for the net change to be 0, that means that I have to add 8 to the equation. So I've added a negative 8 here, and so I have to add a positive 8 here so that the net change is just 0. So once I do that, I'm able to, again, factor what's inside of the parentheses, and this factors into x plus 2 to the second power. So I have negative 2 times x plus 2 to the second power, and these two become 9. This is now in standard form with a vertex at negative 2, positive 9. Standard form is also called transformative form. So you might see either one of those terms used in books or in your homework assignments. They might be referring to the standard form or the transformative form of the quadratic function. In this case, my a is negative. It's a negative 2. So this would be an upside down parabola. So therefore, this vertex would actually be a maximum point. Okay, so there is more than one way to identify the vertex of a parabola. And so what I just did was using the completing the square method to put the equation in standard form or transformative form, but we can also use a formula. So this is just an explanation of what I was just discussing. When a is positive, the parabola faces upward, and when a is negative, the parabola faces downward. And we call a the leading coefficient of the second degree polynomial. So when we're using a formula to find the vertex, you need for your equation to be in this form, not in that transformative form that I just mentioned. So you need to be able to pick out your coefficients of a and b and then plug it into a formula. So the x-coordinate of the vertex is negative b over 2a, and the y-coordinate is going to be when you plug in negative b over 2a in here for x and simplify that right side of the equation, then you'll be able to find the y-coordinate. So that gives you the same results as the previous technique that I showed you. It's just a different option. And again, like I said in earlier problems, when your parabola is upside down, it's an upside down U, you're going to have a maximum point. And when your parabola is facing upward, that's when A is positive, you're going to have a minimum at your vertex. Okay, so here I want to identify the maximum point and the domain in the range of y equal to negative x squared plus 2x minus 5. This will be an upside down parabola. So when they're asking for a maximum point, they're really just asking you what is the vertex. So I'm going to apply this formula right here. So my a is negative 1, my b is 2, and my c is the constant negative 5. You only need a and b for the formula. So the x-coordinate of the vertex will be negative b, so that's going to be negative 2 over 2a, so that's going to be 2 times negative 1. That works out to be just 1. Then, to find the y-coordinate, you plug in 1 right in here, and so that's the work that you see here. So it'll be a negative, and then that's outside of 1 squared plus 2 times 1 minus 5. That works out to be negative 1 plus 2 minus 5, which simplifies to negative 4. So the vertex, or the maximum point, is at positive 1, negative 4. And you could have done it the way I did in the previous two examples by the completing the square method. That's right here. I would have had to factor out a negative 1 first and left this as x squared minus 2x. Then take half of negative 2 and square it. That's 1. So whatever you add, you have to take away. So this one is actually a negative 1 because of the negative on the outside. So that's why I add 1 here. So then you factor this trinomial inside of the parentheses, and this factors into x minus 1 to the second power, and these two become minus 4. So this gives you the result of 1, negative 4 as well. So you don't have to do it both ways. I just want to show you that either way will give you the same result. Okay, So now domain and range. So the domain of any polynomial function, and a quadratic function is a polynomial, will always be all real numbers. So my domain is all real numbers. The range has to do with the direction of the parabola and its vertex. If this is an upside down parabola, I'm just going to sketch it very quickly, with a vertex at 1, -4, so 1, -4 is around here somewhere. And then the parabola is facing downward. It goes like this. Doesn't really matter what the other points are. In order to describe the range, I can use this picture to help me. So you read your range on the y-axis. Both sides of this is showing that this is going towards negative infinity, and then it increases until you get to this point here, which is my maximum at -4. So my range is from negative infinity to -4 with a bracket around the -4 because -4 is part of the range. That's actually where the vertex exists. Um, so remember, we talked about x and y intercepts when we were graphing lines. They also exist or could exist with quadratic functions. So the x-intercept or intercepts, there could be two, is where the graph crosses the x-axis. In other words, that's when your y is equal to 0, and then you solve for x. And your y-intercept is where the graph crosses the y-axis, and you find that by letting x equals to 0 and solving for y. So here we're going to find the vertex as well as the x and y intercepts, and then we'll sketch the graph. So with those points and knowing what the shape of the parabola is, we have plenty of information to sketch the graph. So I used the completing the square method here. So I took half of 4, which is 2, and I squared it. So I added that, and then I took that away. This factors into x plus 2 to the second power, and these two collapse into -9. So my vertex is -2, -9. I have a y-intercept, that's the easiest one to find, when x is 0. So if you plug in 0 in here, you'll get y is equal to 0 squared plus 4 times 0 plus 5. That means when x is 0, y is 5. That is your y-intercept. And your x-intercepts will usually require a little bit more work. That's when you let the y equal 0. So I need to solve this equation. This is considered to be the standard form of the equation, which is different than standard form of a function. So when I factor this, I get x plus 5 and x minus 1. That gives me two solutions, -5 and +1. So those represent two x-intercepts, and those points are -5, 0, and 1, 0. So here are the points that I found. -2, -9 is my vertex. -5, 0 is my x-intercept. 1, 0 is the other. It is definitely an upward-facing parabola. The leading coefficient here is a positive number. And so there you have your graph. So I didn't ask for domain and range in this question, but we'll just go over it. The domain, like I said, it's all real numbers, but the range in this case, if you read it from bottom to top, this is the smallest number that y can be, and then it increases on both sides. So your range is from -9 to infinity, including -9. Okay, so there's a lot of vocabulary. Understanding the vocabulary is just as important as being able to do the math. So please make sure you approach studying in that way to understand what all the terminology means. All right, so in some cases, you can't solve a quadratic equation by factoring the way I did here. So it is helpful to know how to use the quadratic equation. The quadratic equation, which is stated right here, will allow you to solve an equation of this form, where it's set equal to 0. And if your solutions are real numbers, then you have found your x-intercepts. If the solutions are not real numbers, meaning imaginary, those would not be x-intercepts. You cannot graph imaginary numbers on an xy plane. So here, you're asked to identify the maximum height, the t-intercepts, and the y-intercept for h of t equal to negative t squared plus 2 minus 2t plus 6. Here the maximum is going to be the vertex because this is an upside down parabola. That negative in front of the t squared means it will be a downward facing parabola. So my vertex is the maximum. So I'm going to this time use the formula. Remember the formula, instead of x I'm calling it t, is that t is negative b over 2a. So my b is negative 2, so that's negative negative 2 over 2 times negative 1. A here is negative 1. That works out to give me a t value of negative 1. Then I have to plug in negative 1 into the original function, and so that'll be negative 1 squared minus 2 times negative 1 plus 7, and that whole thing works out to be plus 6, and that whole thing works out to be 7. And so my vertex is at negative 1, positive 7. Therefore, to answer the question, the maximum height is at 7 units. Okay, so now I need to find my t-intercepts. And this is not factorable. Even if I tried to find two numbers that would give me a product of 6 and a sum of negative 2, that's not going to work out. So I'm just going to plug in the values. And so remember, this is negative b, but b is negative already. This b is negative. So that's why negative negative 2 is why I have a positive 2 there. Plus or minus b squared. So negative 2 squared is 4. Minus 4 times a, which is negative 1, times c, which is 6. So I've plugged in the a, b, and c here, all over 2a, 2 times negative 1. Simplify this, you'll get positive 2 plus or minus the square root of 4 plus 24 over negative 2. Add what's inside of the radical, you'll get 2 plus or minus root 28. So I'm basically plugging into this formula. Over negative 2. But 28 is 4 times 7, and the square root of 4 is 2. So that comes out of the radical. So I have 2 plus or minus 2 root 7. But then this negative 2 divides into this, and it divides into this. So you're left with t is equal to negative 1 plus or minus root 7. Those are real number solutions. They're irrational numbers because of the root 7, but they still are real numbers. That's something you can actually plot on an xy plane. You just can't plot imaginary numbers. So if I were to add and subtract these two numbers, when I subtract them, you would get that t is about negative 3.6, and when I add them, you would get that t is about 1.6. This curly equal sign means approximately equal to, so I rounded there. So I now have my x or t-intercepts. My y-intercept is when t is 0. So if you plug in 0 into the original function, you'll get 6. So y-intercept is at 0, 6. So here's the vertex at negative 1, 7. Here's the y-intercept at 0, 6. I have my two t-intercepts. This is negative 3.6, and this one here is at 1.6. Connect the dots from left to right, and there is my downward facing parabola. Again, if you were asked for domain and range, the domain would be the same as the other ones I did. Your domain here would be all real numbers. And your range, when you read this from bottom to top, it starts at negative infinity, and it goes all the way up to your vertex, which ends at 7, your maximum height. Okay. So when your function is in the form of standard or transformative form, which is f of x equal to a times x minus h to the second power plus k, then you'll have either a maximum or a minimum value at of f at the value of x equal to h, because remember that h coordinate is the x coordinate of the vertex. So like I've been mentioning, if a is positive, you're going to have a minimum because it will be an upward facing parabola, and when a is negative, you're going to have a maximum at h, because it's a downward facing parabola. So you would call the minimum value the k, and the maximum value would be the value of k. So you have to pay attention to how it's worded. Are they looking for a point? Are they looking for the x value? Or are they looking for the y value? When they ask you for a maximum value or a minimum value, they're definitely asking you for the y value. Okay, so here we want to determine the maximum or minimum point for each of the following. So the one here in green, part A, says y is equal to 2 x minus 3 to the second power plus 4. My a is 2, which is a positive number. Then we have a minimum at the vertex, which is at 3, 4. Right, here you were asked to find the point, so that's why I stated both coordinates. For the second one, for part B, I have y is equal to negative x plus 1, and here I lost to the second power, minus 5. So there is your quadratic function in standard or transformative form. Here the a is a negative 1, which is this, which is a less than 0. And therefore we have a maximum point at the vertex, which is negative 1, negative 5. So you always take the opposite sign of the x and take this exactly at face value. Okay. And again, the maximum or minimum is just another term for the vertex. Okay, so here we have an example. The gas mileage m is modeled by the function m of s equal to negative 1 over 28 s squared plus 3s minus 30 for s between 15 and 17, including 15 and 17, where s is the speed in miles per hour and m is measured in miles per gallon. What's the car's best gas mileage? So in other words, we're being asked to find the maximum value for mileage, and m is mileage. So a maximum is going to be a vertex. This is a quadratic function. It's s to the second power. That's the degree. And I know it's a maximum, not only because that's what's being asked in the problem, but my leading coefficient is negative, which means the graph of this would be an upside down parabola. Wherever the vertex is, I have my maximum. So I need to solve for the vertex of this. So a is equal to negative 1 over 28. I'm picking out this information from here. B is 3 and C is negative 30. So S is equal to, and now I'm using the formula, negative B over 2A. So that'll be negative 3 over 2 times negative 1 over 28. The 2 and the 28 leaves me with negative 1 over 14. So this is negative 3 divided by negative 1 over 14. And remember, with fractions, you change division to multiplication and take the reciprocal of the second one. So it's negative 3 times negative 14, which gives me 42. That is S, right? The speed. That's not answering the question. I have to figure out what the M is. So now I take the 42 and I plug it into the original function. And so I have negative 1 over 28 times 42 to the second, plus 3 times 42 minus 30. And this whole thing reduces down to negative 63. These multiply to give you 126 minus 30. And when you add and subtract those numbers, you get 33 miles per gallon. So the maximum value of mileage that you can get is 33. Okay, so here's a problem for you to try. You're asked to write the equation y equal to x squared minus 4x minus 5 in standard form. Identify the vertex. Is the vertex a maximum or a minimum value? And then state the domain and range using interval notation. So that's something you can try using what was taught in this lesson. Good luck.